Hello students. Now that we have studied partial fractions from the board's point of view, it's time that we see it from the entrance point of view. Let's take the very first question in this particular module. The question is integral of 3x plus 2 upon x minus 2 the whole square up into x minus 3 is equal to which of the four options? My dear students, this question is belonging to partial fraction, and to be very precise, it is of the type where we have a repeated linear factor. Let us see how the solution is. But before I go to the solution, I am seeing something here. If you observe, in the question I have a factor of x minus 2, but in option B there is a factor of x plus 2. It's impossible to get that factor, therefore option B cannot be the answer. Likewise, if I see further, x minus 3 is in the question, but option D is talking about x plus 3. They must be crazy. So therefore option D is not the answer. So the fight is between option A and C. My dear students, this question has been picked up from some entrance exam. So they ask such questions in the entrance exam. Now let us see the solution. Now for us to solve this, we will have to assume this equal to what? Let us write that as a upon x minus 3. The non-repeated factor gets normal treatment. Now x minus 2 is repeated. So let us write b upon x minus 2 plus c upon x minus 2 the whole square. Now my dear students, let us see something. First let us take LCM. 3x plus 2 is equal to a into x minus 2 the whole square plus b into x minus 3 into x minus 2 plus c into x minus 3. Is that okay? My dear students, this is what we have to find the value of a, b and c. Now, should we find a, b and c? Entrance may not allow us that much time. We need to observe something. If you observe the options a and c which are left with us, their first part of the answer is the same. Now this will be obtained when we find the values of a and b. So it is clear to me the value of a and b both will be 11. One will be plus 11, the other will be minus 11. Is that okay? Now what needs to be decided is whether I'll get a plus 8 or a minus 8 in the final answer, and that will be decided by the factor of x minus 2, which is not in log. So we need to find c. The bottom line is, let's go to find c. We cannot find c directly, or let me say to find c we'll have to put x is equal to 2. So let's put x is equal to 2 in the equation. We get 6 plus 2 is equal to c into bracket 2 minus 3, that is c is equal to minus 8. Now my dear students, don't jump to the conclusion that the answer is a. C is not the answer on integration, it is the answer before integration. Now let us see further. Now if I have to write that, the partial form will now become equal to, can I say a upon x minus 3 plus b upon x minus 2? I am not interested in these two. Plus of minus 8 upon x minus 2 the whole square. Now if I keep the first part as it is and integrate the second part, I will get minus 8 integral of x minus 2 the whole raised to minus 2. Now my dear students, for your understanding, let us take the rough work. Minus of 8 into x minus 2 the whole raised to minus 2 on integration will give me minus 8 into x minus 2 raised to minus 1 upon minus 1. That is effectively nothing but 8 upon x minus 2. That is a plus 8 upon x minus 2. Now plus 8 is present in option C. Therefore my correct answer is option C. Is that okay, my dear students? So we managed to solve the sum without finding the values of a and b. Let's take one more example. Integral of dx upon x into x raised to n plus 1. A very important question. We are using a generalized example so as to make it as a formula. Now my dear students, here there is a problem. We have two different functions in the denominator. The functions are x raised to n and x. We will convert the denominator as a function of x raised to n completely, and that is possible if I divide the numerator and denominator by x raised to n minus 1. Multiply the numerator by x raised to n minus 1, multiply the denominator by x raised to n minus 1. In the process we get x raised to n in the denominator entirely. Now my dear students, The denominator is x raised to n. The numerator is its derivative. Constant needs to be adjusted. So let us put x raised to n is equal to t. So we can say that n into x raised to n minus 1 dx is dt, or let us say x raised to n minus 1 dx is equal to dt upon n. Now let's proceed further. So the integral will become 1 by n into 1 upon, integral will be 1 by n into integral of 1 upon t into t plus 1 dt. Now my dear students, here the difference between the two terms is a constant. So let us go to write that as 1 upon t minus of 1 upon t plus 1 in the integral sign. 1 upon the smaller number minus 1 upon the larger number. So can I say further, on integration I'll get 1 by n log of t minus log of t plus 1, which is nothing but log of t upon t plus 1 plus c. Now t was x raised to n. So let us write that. So we will get is equal to 1 by n log mod of x raised to n upon x raised to n plus 1 plus c. This is nothing but my option A. So the correct answer is option A. Now my dear students, you may remember this as a formula for sums of this type. Let us take one example of the same type. Now my dear students, let's see the example. In this case, if you compare with the result which I have given, now can I say the value of n is 10? So if the value of n is 10, my answer will start with 1 by 10 log mod of, and that is nothing but option B. So you can check, we have derived the generalized result. In exams they may ask like this, so you may remember it. That's all we have in this module. Thank you very much.